Welcome to Sankey Flow Show MiniTutorial. This one is about adding simple logic to a diagram. You will learn how to configure a diagram in a way which lets you change values with a minimum effort. You need a pro license to access the features shown in this tutorial. Why should we add logic to our diagrams? Here is an example. It is a simple chain of items. Without any logic, we can change the value of the first item in the chain and see that only the first connection becomes a wider line. But in this example, we obviously want to push the changed value along the chain from the left to right. In this tutorial, you will learn how to achieve this behavior automatically. First, let us have a closer look at the standard behavior of Sankey Flow Show. We have a branch connection in this example. The values of the branches are automatically summed up to the value of the trunk. When we change the value of item A1, then we see the value of the trunk is automatically calculated and it changed now to 7. Maybe you noticed that the width of the trunk did not change, but all the other lines became a little bit narrower. Our diagram has a property named maximum width, and this setting applies to the highest value in a diagram. Currently in our diagram the highest value is 7, and the respective line is shown with a 140 pixels line. I'll show you a small trick. It helps us to better track the changes in the diagram. We add a new connection to the diagram and enter a higher value. I enter 15. Now this is the highest value in the diagram. We change the setting of the maximum width to 400, and then we set the color of the new connection to white. When we change the value of item A1 again, we can see that the trunk is now showing the changes. But now back to our example. What happens when I change the value of item B? I set the value to 8, and you can see that all branches are scaled proportionally. The most simple logical item type in Sankey Flow Show is fixed values. It prevents values from being changed automatically. I have set item A2 to fixed values, and when we now change the value of item B, then just the values of A1 and A3 are automatically adjusted. Let us also set B to fixed values. And now we change item A1 and see that only item A3 is adjusted automatically. The item type user input is very similar to fixed values. The only difference is that input fields for the item values are showing up in the diagram's data input form. Now let us add logic to the item chain. A is already set to user input, and I'm gonna set B and C to fixed ratio. The input value and output value of B and C are currently equal, so their ratio is 1:1. When we now change the value of A, the other values in the chain are adjusted accordingly. The third example shows the behavior of the setting fixed ratio in more detail. There are multiple inputs and outputs, and when we change a value, for instance multiply it by 2, and when we change a value, for instance multiply it by 2, then all values are multiplied by 2. The next example shows a combination of logical types. A1 is set to user input, A2 and A3 are fixed values, B is fixed ratio, and C is set to auto adjust. I change the value of A1 and you can see the lines changing. What happens when I try to set also C to fixed values? Sankey Flow Show shows a message meaning that at least one automatically adjustable item is required. So let us set A3 to auto adjust. Now we can change C to fixed values. And when I change the value of A1 again, you can see that the value of A3 is changing automatically. The next example is very similar. The only difference is that A1, A2 and A3 are connected to B not with a single connection, but with a separate connection each. In this situation, item B needs the type SumUp from in to out. And we get the same behavior as seen in the previous example. Finally, the last example in this tutorial contains an item C, which is set to sum up from out to in. When we change item A1, then the path to item C1 is adjusted accordingly. The best way to learn how the logic functions of Sankey Flow Show can be applied efficiently is to try out a realistic example. I recommend to first complete your drawings and then after add logical types to the items in a second step. The turn is on you now. Try out what you saw on www.sankeyflowshow.com.